Okay, I asked you to do the questions on 488, 489, well, just three of them, starting with number 24. Is that blurry? There we go, that's better. It says a Fletcher trolley apparatus, and you're like, what the heck is that? Well, it tells you. It consists of a 1.9 kilogram cart on a level track. Okay, so here's my level track, and here's my 1.9 kilogram cart. Attached to a light string passing over a pulley, and holding a 0.5 kilogram mass. So here's my 0.5 kilogram mass. Suspended in the air. Neglect friction. And so there's no friction on the 1.9. Obviously, there's none on the one hanging in the air. Okay, and the question wants you to find the tension in the string when released and the acceleration of the trolley. Well, the book strikes again. You have to find the acceleration first, and then you can find the FT. All right, so if we draw our forces in, this will be FG. I'm going to call this guy 2. It was named last. And there's no friction. So if we were to draw our system in a straight line, the only thing pulling this way is FG2, and it's positive, and there's nothing pulling backward. So you would do the sum of the forces is equal to M total A, and the only one is FG2, and that's going to be equal to M1 plus M2 times A, and you're solving for A. So FG2 is M2G divided by M1 plus M2, and now you can fill your numbers in. M2 was the 0.5 kilograms times 9.81 meters per second squared. On the bottom, 1.9 kilograms plus 0.5 kilograms. So on the top, 4.905. On the bottom, 2.4. So it's going to be something just slightly bigger than 2. 2.04375 meters per second squared. Now, once you have that, now you can do the tension. Probably the easiest one to do it on is M1. This is the one I called M1, by the way. Why is it easiest to do it on M1? Because look, there's only one force. Here's M1, and the only force that we're caring about is FT. There's no friction backward, and who cares about the two in the y direction? They just cancel each other out. And so if we do sum of the forces is equal to M1A, it'll just be FT, which going this way for M1 is positive, is equal to M1A. So FT has to be equal to, M1 was 1.9 kilograms times that 2.04, etc., meters per second squared. And when you do that, you should get an FT of 3.883 newtons. It's a few more decimals, but if you had done it on M2, it'd be FG2 acting down, FT acting up. Down would be positive because that's the way M2 is moving. You would do sum of the forces is equal to M2A, and so it would be FG2 minus FT is equal to M2A. And you're solving for FT, so bring it over, bring this over. So to be M2G minus M2A equals FT. Fill in your numbers, 0.5 kilograms, 9.81 meters per second squared, minus 0.5 kilograms times 2.04, etc. And lo and behold, guess what you get? 3.883 if you haven't rounded your acceleration. Okay? So it doesn't matter when you're doing the tension which one you do it on. It's just sometimes one of them is easier, but the other one can always serve as a check. All right, number 25. Number 25 says a 40-gram glider on an air track is connected to a 25-gram mass suspended by a string passing over a frictionless pulley. Now, an air track is just like an air hockey table, so that the thing that's on it floats on it. Okay, so in other words, no friction again. Yeah, I did find, I was going to say, oh shoot, I didn't finish 24, but I did. Okay, so it's a 40-gram glider here, and the mass hanging down is 25 grams. When the mass is released, how long will it take the glider to travel to 0.85 meters? So it's looking, it tells us delta D, it's released, so VI will be 0. How long? You're looking for time, but before you can find that, you're going to have to get the acceleration. It looks just like number 25. There's an FG, 2 going down, nothing going back. Do the sum of the forces should equal M total A, and you should have FG2 is equal to M1 plus M2 times A. So A is equal to M2G over M1 plus M2. Now, they gave us the masses in grams. Do I need to switch them? I actually don't, as long as I'm not finding a force, because I can put my 25 grams in here and multiply it by 9.81 meters per second squared, divide by 40 grams plus 25 grams, and the grams are going to cancel. If you want, you can divide the 25 by 1,000 and the 65 by 1,000, but I'm pretty sure you'll get the same answer whether you do that or not. You get 3.773 meters per second squared. And then once you get that, you can now find the time just using delta D is equal to VI delta T. 1/2 A delta T squared. This goes to 0. So delta T squared is equal to 2 delta D over A. So 2 times 0.85 over the A that you just found, 3.773. There are more decimals. And don't forget to take the square root, and when you do 0.6712, etc. seconds. All right? So that's number 25. Number 26 is a table with a mass in the middle. I'm going to call that one M2, M3, and M1. Okay, so M1, M2, M3. And it tells us M1 is 288 grams. I said 288, but I think it's really 228. Yeah. M2 is 615. Always believe what I write down more than what I say. And M3 is 455 grams. And it says the coefficient of kinetic friction is 0.26. So mu is 0.26. And the mass 3 is 1.95. So this guy, 1.95 meters above the floor. What'll be the time interval between the instant the mass has started to move and the instant M3 hits the floor? So M3 is moving down. This way is positive. This way, then, must be negative. And friction, therefore, will be acting backward on number 2. So if we were to draw them in a string, and pulling forward will be FG3, it'll be positive. Pulling backward, FG1, and friction on 2. Do the sum of the forces. Is equal to M total A, so it'll be FG3 minus FG1 minus friction from 2 is equal to M1 plus M2 plus M3 times A, solving for A. So FG3 is M3G minus M1G minus mu M2G, because it's just friction, divided by M1 plus M2 plus M3. Again, you can decide, do you want to change to grams or kilograms? Again, as long as you're not finding the force, it doesn't matter. So it'll be 455 grams times 9.81 meters per second squared. I should have factored the G out. Minus 228 grams, 9.81. I'm probably going to run out of time here. Meters per second squared. Minus was it 26? Yeah. 0.26 times 615 over 9.81 divided by the 228 plus the 615 plus the 455. Okay? And again, the grams cancel. And when you do this, you should get 0.5071